All right, guys. Section C. So we're talking about states of matter. Now, we all know the states of matter are solid, liquid, and gas. So that's not a big deal. But what we have to understand is what's the difference between solid, liquid, and gas, and that's particle distance. So in solids, everything's pretty darn close together. All right. So everything's like pretty lined up. In liquids, what we get in 2, 4, 5, 6, 7, 10, 11, 12. Everything's still very close together, but particles are able to slide by one another. So there's movement. Then we have gases. And so here's 1, there's 2, there's 3, there's 4, 5, 6 will be over here, 7. Gases are spread way out. And so what we talk about here is solids and liquids are known as the condensed states of matter, whereas gases are spread way out. And that's why we have they behave on like a little bit of a different plane. And so we'll have our own unit on that. All right. So properties and changes, physical properties, all right, and changes. All right. Physical. This is no identity change. All right. So something like this is where you can start coming up with examples. All right. Is like, what are some things where we don't change the identity of something? So physical would be like state change. All right. Because if you take water and you melt ice, it's still water, just it's now in a different state. So we haven't changed its identity. Temperature would be a physical property. Mass is a physical property. These things do not change the identity of what we're looking at. Whereas a chemical situation, this is where we change the identity of something. Like we have a different identity. We have changed it. All right. When you burn hydrogen, you totally change it. It is no longer hydrogen gas and oxygen gas. It is something totally different. So we have a change in ID. So that's what we have there. All right. And as we move on, we're going to do extensive. And intensive. All right. These are two things right there. So extensive, this is dependent upon amount. I know I'm looking at the paper here, but this depends on amount. So how much of it you have. So like an extensive property would be like mass, right? Because how much you have is dependent upon is going to change what the mass is. Intensive, not. See, I'm trying to not. Amount dependent. And hopefully I spell this word right, or else I'm going to look foolish. Dependent. So here you have extensive properties that are dependent upon amount and intensive properties that are independent of amount. They do not care. They not amount dependent. It doesn't matter how much, it's going to be the same. So if you have like a gallon of water, or if you have like a Culligan water jug of water, it's still that clear liquid. And so we don't have to like talk about amounts there. So intensive property would be like temperature, right? You can have a small amount that's the temperature, or you can have a large amount. It doesn't depend on amount. Extensive does depend on amount. So there we go. These questions that we have right here, as we drop down here and look at these graphs, we're going to talk about this in class. All right. So as you go through these are things we're going to have touch points on in class.